Now, we're going to talk about the number of infinity branches, which are 4. They are 4. Since the limit when x approaches to 1 for f of x is going to plus and minus infinity. Watch it. We have here 1, 2, 3, 4. They are 4. Number 5, no, before, and limit when x approaches to plus and minus infinity for f of x will give you plus and minus infinity. In number 5, the function is increasing on the interval from negative infinity till negative 1 closed. Watch it. It is decreasing from here, decreasing from here to there. It is decreasing from here to there, which is also from, what do we call it? It is decreasing also from here to there and increasing from here to there. It is increasing from here to there. And you can talk about increasing and decreasing from the table by looking to f dash of x, by looking to the signs. If it is positive, so that means it is increasing. Watch it. It is rising up this row. And when you have negative, so that means it is decreasing downward. This means you have decreasing. And also here, after the gap at x equals 1, you can return back negative again, which means decreasing, going downward, and a positive means in the first derivative increasing, which means going upward. Now, if you want to write this interval, we can write them easily. The function increasing on the interval from negative infinity till negative 1 closed union from a 3 till plus infinity. And then, and the decreasing on negative 1 till L1. Watch it, from negative 1 till L1, and make it at 1 open interval because L1 is not included to your domain. Watch it, from negative 1 till L1. Union from 1 till 3. From 1 till 3. It is decreasing also from negative 1 till 1. It's decreasing from 1 opened till 3. It is also decreasing till here. Okay. The next step is talking about the function has extreme values on 3 and 6, which is minimum point, which has minimum point here, and it has a maximum point at negative 1 and negative 2. Negative 1 and negative 2 is the maximum point. This is in the graph. In the table, you can see it here. Negative 1 and negative 2 is the maximum point, and at 3 and 6, it is minimum point. Number 7, the function concaves downwards completely on the interval from negative infinity till that 1. From here to there, from negative infinity till 1. You can see the concavity downward. Actually, to discuss the concavity, you have to study the signs of the second derivative, which can be negative when it concaves downward and positive when it concaves upwards. So it concaves also here upwards completely from 1 till plus infinity. Make it at 1 open because it is not defined at 1 from the domain. The last one is 8. The function has no inflection points because it has a gap between the two symmetric graphs of this hyperbola. It's a hyperbola. Next example, which is example number 4, f of x equals x plus 4 over 2x minus 3. And here you can see that the power up is equal to the power down of the x-axis. Then there will be a vertical asymptote and a horizontal, and there will be no slant asymptote. Everything is clear now in that table, which can be divided to x, f dash of x, f double dash of x, then finally f of x, which is defined from negative infinity till positive infinity, except that the block column at 3 over 2. And it's clear in that graph. Watch it. It's clear for you where are the horizontal asymptote and the vertical asymptote. Now, let's answer the questions. The first question was, the domain. The domain of the function x belongs to R except to 3 over 2, or from negative infinity till 3 over 2 and make it open like we said before, union to the interval from 3 over 2 open till plus infinity. This means at 3 over 2 there is a block here in the table and there is here a broken line. That means it is not included to our domain. The next is the range of the function. The range of the function is y belongs to R except at half, or from negative infinity till half opened union from half till plus infinity. Look, here you can see that from f of x you have half is the largest value here, and negative infinity is the smallest. So we're going to start from negative infinity till half, and here also from half, which is the smallest, to the plus infinity, which is the largest. This is how to describe the range in the table. How to describe it in the graph? We can start from negative infinity like that till half, and the half is not included. Then start from half, open interval, till plus infinity. This is how to describe y. 3. The equations of the asymptotes. The first one, the vertical one, is x equals 3 over 2. You can take it from here. You can take it also from here. 3 over 2 is the value of the vertical asymptote. And here you can find it from here by equaling the denominator by 0 and find the value for x. By moving the 3 to the other side, change the sign, then divide x by 2. Then you can get x equals 3 over 2. From the graph, you can get it from here, 3 over 2, which is the block column. Or you can get it from the graph by looking to the broken line, which is x equals 3 over 2, which the curve never touched it. When we are talking about the horizontal asymptote, we can get it from the range. Watch it from here. When x approaches to negative infinity, our function goes to half. And when x approaches to plus infinity, our function goes to closer to half. Y equals half. This is from the table. And this is from the range. And from the graph, you can see it as a horizontal asymptote, which is y equals half. Because we have a horizontal asymptote, like usual, we say that no slant asymptote, which is not drawn in your graph. The fourth step is the number of infinity branches. We have actually 4 infinity branches. Let's count them. 1, 2, 3, 4. 1, 2, 3, 4. They are 4 infinity branches. Since the limit when x approaches to 3 over 2 for f of x is getting to plus and minus infinity. You can see it in the table. 3 over 2, when we are getting closer to 3 over 2 from the right side, our curve is going to plus infinity. When the x is going closer to 3 over 2 from the left side, our function is going down till minus infinity. And the function is decreasing for all x belongs to R, except 3 over 2. You can talk about decreasing and increasing in the graph by looking from left to right, not opposite. From left to right, watch it. From left, we are going downwards. Then, after this gap, you can go to that side and that curve to describe it. From left to right, it is going downward. This means it is decreasing. So it is decreasing for all real numbers except at the domain, which is x equals 3 over 2. And this represents a hyperbola also. The next step is the function has no extreme values, no maximum, no minimum. That means the first derivative here can't be equal to 0. The function concaves downwards on the interval from negative infinity till 3 over 2. It is not actually clear in your table, but it is clear in your graph. Like that, going downwards, 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 and this concavity is partially, not completely. From negative infinity till 3 over 2, and make it open at 3 over 2 because it is not included to your domain. And when you are talking about concavity upward, it is here, concaves upwards on the interval from open interval from 3/2 till plus infinity. It is also partially concavity, not completely. In number 8, the function has no inflection points. No inflection points because there is a gap between these two symmetric graphs forming this hyperbola. Thank you so much for watching this video. If you enjoy it, give it a thumb up and don't forget to subscribe, then turn on notifications. Good luck. Thank you.